Hi, can everyone hear me clearly? Fantastic. How is everyone doing? This is the last workshop of the day, I think. So I am officially the last thing standing between you guys and I believe the drinks after this. So I'll try and keep it brief, but the focus of this session is AI and ML simplified. We're going to start right at the very bottom and start to work through both a variety of deploying a large language model and the reasons why you'd want to do that as opposed to using a platform like ChatGPT. My background's predominantly in enterprise AI. I spent my length of my career working with big companies like AstraZeneca and Eli Lilly, working in deployments of machine learning. And obviously the regulatory and compliance need cases for that end up creating really complex use cases for machine learning. One of the things I'm really passionate about is making sure you can take autonomy and ownership over those things. And what I really want to do is make sure that everyone here takes away a little bit of something from the workshop. So if you're going to follow along, and it's not mandatory, you can sign up using this link here. This will get you into a Civo account. You can then do a deployment from inside there. And then the most important part is this is the GitHub repository with all the code that we're going to be going through today. This is a complete code base, so if you want to get home and deploy this in your own time, you're more than welcome to. This is actually a really valuable asset that will be able to take money off the ChatGPT bill and also give you a lot of autonomy around your machine learning deployments. So I think, to start out, why would you want to replace ChatGPT? And actually, there's a lot of questions we have right now with OpenAI developing these models, and there's lots of conversations that happen around it, but I'm sure everyone kind of understands and knows the majority of the reasons why, there we go, this works a bit better. The majority of the reasons why people try to pick up these types of machine learning models is because open source is doing a lot to catapult large language models into production. And the reasons behind that is actually things like Meta's release of Llama 2 is a really good example of actually where you can get a realistically similar performance with an open source model that you can with something like a ChatGPT model. Some of the things that are becoming really interesting is actually the focus on large language model bottlenecks seems to be around data and data ownership. And the trends we're seeing around that is actually it's quality over quantity with training data for large language models. And what people are starting to realize is that data that we're all scraping on the internet to build these large language models is running out. And the last sources of these data seem to be actually inside companies, and companies are realizing, hey, I've got a unique value proposition here by training a large language model using the data inside my company. And actually, if I give that away and use ChatGPT, I lose that competitive advantage. There's situations where, like regulatory and compliance reasons, why you might not want to put your data across on a software as a service. Great examples of that are people's personal information. They seem to be very much so in the focus of how we personalize large language models, but actually the question is, can you take your customers' information and can you send it to a model provider and use it? Particularly for large use cases where you've got large enterprises with 50,000 people, ChatGPT licenses can be considerably expensive and are actually more than the standard average spend of an enterprise. But then the really interesting part about that is everyone's talking about fine-tuning and quantizing models right now. And that's becoming a little bit of the hot trend. And OpenAI still haven't got a response to that, and still haven't got an ability for you to be able to take control and autonomy over your own machine learning model. And as software engineers, we always like to build our own, right? So there's a lot going on here, but I promise it's not as scary as you're going to think. So what we're going to try and do today is we're going to use the Civo Terraform provider to start to do a machine learning deployment. On that, we're going to configure GPUs to be able to back the large language model behind. The reason why you'd obviously use a GPU is to increase the performance and accuracy of the model that's being used, normally by a figure of like 60 to 70x. Alongside that, we'll put together an inference endpoint, which can be picked up and used by other systems and services, which mirrors a microservice type of integration. And then as we go through that as well, we'll give the end users a user interface to test and validate that using a open source interface, which will hopefully mock what people log into when they go to ChatGPT. And the really exciting part, and this is something you can take away and build your own implementation for, and I'd love to see forks and branches, is actually going to give you an example Python application, which out of the box will use a lot of the integrations we've set up today. So if you've got a plan to build a startup or a company or even a simple app using a large language model, you can grab a hold of this, pull it, and just write code directly in there. And your integration, setup, deployment, CI/CD are just all done for you. And if I can't make that any better, this is a one-to-one drop-in replacement for ChatGPT. So if you're using anything that uses the OpenAI API, you can just take exactly what we're going to pull out today and put this in. A really good example is actually if anyone was in Joey's workshop earlier, where he used the OpenAI API. After you've got this set up, you can really simply just put it in, and you'll be running on an open source model that you have full control over, full ownership over the data, and is running on Civo. Alongside this in the repository, you will find some example integrations for OpenAI directly, LangChain, which I believe is what Joey used in his workshop earlier, Llama Index, and Microsoft AutoGen. The Microsoft AutoGen is actually an AI agent that you can play around with. You can ask it to build you a Python web application, and it will go away and pull a Python web application for you. And then also some of the engineers at Civo have been working really hard to put actually CI/CD around this as well, so you get a very simple GitOps approach, but this gives you hopefully completion that this application can be used in a production setting, and if you had a software team that needed to use this, they could pick up and run with it at scale. So, let's jump in. And for anyone pulling the repo, this is most likely what you see. Pull this down locally. The important components I want to talk about today is Ollama. Has anyone heard of Ollama before? 1, 2, 3. Fantastic. So the guys at Ollama are brilliant. They do a lot for the cloud native community, but most importantly, they've been spending their time recently building a single interface. You can pull all 400 open source large language models that are hitting the industry in a single way. They also provide really easy wrappers that put around that, and I think out of everyone today, the people who are putting an integration point their challenges where OpenAI are most likely. We're going to use the NVIDIA device plugin to get the GPU that's backing this to be able to power that, and there's some configuration options already put in there for you, so it's a simple one-click deployment. And then, of course, the Python large language model will be building behind. All you really need to get this to work is a Civo API, so a Civo account and a Civo API token. If you're registering on the link that you saw earlier, go into your account, pull out that token, put it into the Terraform as provided here. And if you just do Terraform apply, you will just deploy this in a single click. We're going to break this down, and I'll go through it. I would feel disingenuous to make you all watch Terraform as I was stood here in front of the stage. So we'll break down the code and go through it. And hopefully if anyone grabs any kind of interesting use cases or questions as we go through, we can start to answer some questions. So, is this clear on all the monitors before I go any further? Fantastic. So, this is the source code repository. We'll break through this a little bit before we watch it in action. But predominantly what you'll see here is 3 core repositories. One is for infra, one is for the application, and one is for notebooks. What you'll see in the notebook section is some scrappy proof of concept integrations, which you can then build on into production. So for example, you can see here is a really standard, close that down. Here is a really standard OpenAI based application. It makes a call using the OpenAI Python library. And the only thing I've done here is actually I've overridden the endpoint it's calling. So instead of going to ChatGPT, we're going to go to an endpoint that I've got set up behind the scenes. We can then prompt and call that exactly how you would a ChatGPT model, and you'll see some outcomes come directly from that. A very similar example can be seen here, where actually what we're doing is we are setting up an AutoGen agent. What this is doing is it's creating a Docker container. You're creating a large language model, and you're saying, hey, go write code in that Docker container and tell me what comes out. So just for means of completion, you'll see in here I've got a very simple request, which is write a Flask application in Python. I've told it what to do and how to put the roots together. I've told it basically send a post request to this endpoint here, which is what we've got set up inside a Kubernetes service. And what you'll see here is actually going to go write some Python. I'll come back to why this is fun in a minute. And the heart of what's happening here is actually a series of Terraform which will provision your Civo infrastructure. So here you have a very simple Civo cluster being declared as infrastructure as code. This is actually provisioning a GPU node pool and putting a single GPU into that. It's provisioning the firewall, which is going to keep these applications safe. And if you've got complex requirements around security, here's where you can say only let this into this particular IP address or this particular port range. This is a stereotypical network implementation, but as you can probably imagine, this is what you attach your firewall to. Here is an example Helm release that we're doing for the demo application which we have. We'll get to this in a little bit later. And then these two components are what drive a lot of the user experience we're going to show you in just a minute around the large language model. So this is an application called Ollama UI. This is a mock interface which replaces the ChatGPT interface. You can go in here and start doing things like simple fine-tuning, make prompts, make calls and responses. If you have non-technical users in your organization who say, no, you can't take ChatGPT away from me, this will help hopefully close that gap for you. And then Ollama, which will provide, and this is a Helm chart definitely worth checking out from the Ollama guys, this will give you an inference endpoint which you can use to just call a ChatGPT model directly. Whilst this is a bit complicated, has anyone in the room configured NVIDIA drivers before? There you go. You saw how slowly he raised his hand. It's not exactly the most fun part of infrastructure as code, but I've done the hard part for you here. This is reusable as another asset that you can look at if you have other large language model or machine learning applications. But effectively what we're doing here is we're provisioning the Kubernetes cluster to say assign these GPUs to this particular type of label. We label the node and say this is a NVIDIA GPU node and say if our application needs so, attach it to. Inside here, you'll see a variety of parameters. So if you want to white label this across to use for your application, just change this and it will rename the application. It will also update some of the HTML inside the apps as well, so you can start to white label across from there. Here I'm specifying a 40 gigabyte NVIDIA A100. I'm specifying a single one of those. This will scale up. I haven't given it a multi-GPU use case yet, but effectively if you did need to scale up, it's as simple as increasing the number of nodes that you see visible here. We're deploying it into the London region. And then here I've put some flags to help make things simple. So if you just want to deploy the inference endpoint, Josh, I don't need all the fancy bells and whistles, that's very possible. You can turn on and off the user interface that we're going to wrap around the endpoint. The demo application, which we'll get to, and then also you can configure if you want to enable GPU support or not. So I've given you a lot of flags here that do the intelligent work in the Helm chart behind the scenes. Hopefully this makes it reusable, and what I really want is for people to come back and say, hey Josh, I built something really cool off the end of this Helm chart. Now, inside here, you will see two particular Helm charts. The deployment is vast and complex, but the important part here is actually I'm injecting an environment variable, which is the inference endpoint of the Ollama inference server. And I'm putting this into the user interface that you will see. I'm doing some control around the ingress to basically manage the internal networking of the cluster. But most importantly, I'm setting up a PVC so that every time we tear this down and put it back up again, I don't have to download 100 gigabyte machine learning models. What you often see as being the largest performance hit is loading that model initial runtime. This will cache that in that PVC, separated away from the application logic. And then this is a service which is built around that. For all of the services you'll see here, these are compatible with Civo load balancers and are set up appropriately. If you want to change the server back to a node port, you can. Civo load balancers are set up so you just change this service type and it will instantaneously boot you a load balancer into the Civo interface. I'll come back to that application. But I think where I'll start is this web application. So to make the jump from code to application, this is the Ollama UI Terraform, deploying this Ollama UI Helm chart. And as I load this in, you get a number of different pieces of functionality. This will cold boot the model, so very quickly I'll say hello. And this is running on Gemma. People know what Gemma is? It's Google's most recent large language model they've released. It's pretty performant. This is a really good model for your use case. However, we'll show you how to access another 399 models inside the Ollama ecosystem if this one doesn't work for you. Now, this works in a very similar way to ChatGPT, where if you click on this drop-down box, I can select Llama 2, I can select Gemma, similar to how you can select ChatGPT 3.5 or 4. Exception here is you're not being charged a different rate for each one. So if you want to load a 70 billion parameter model into this, it will not cost you any more. Might take a little bit longer to generate. This is one of the advantages of owning the model on your own infrastructure, is you're not paying per token. And in some use cases, particularly with large context windows, where you're trying to put as many tokens through as possible, ChatGPT gets really expensive, right? Really, really expensive. You can also make these models compete. So I can make a request to Llama and Gemma at the same time and let one of those models decide which one of those would be best appropriate for me. It builds out other functionality, so you can upload a document, something like if you wanted to write an RFC for some software, and you had a couple of examples of different RFCs that you had, and say, hey, look at these and make me a new document that goes alongside it, you can do. And that's available from within here. It has a similar functionality to how GPTs, I believe, in ChatGPT work, where you can create agents through a series of prompts and effectively prefix those inside there. However, the fun part comes when we go back to here. I go into settings, and actually, if I click this link here, here are all the different models, and I think actually Code Gemma might be a good example of one that came out recently, but if not, here's the new Snowflake Arctic model. That came out, and I read about it this morning. If we want to pull that, I can copy and paste this across. Here is the Databricks open source general LLM. This one apparently is topping leaderboards. This is the Wizard LM2, the one I think in the AI panel we talked about being better at coding than GPT-4. And you can really simply just pull these across. The best part about where this gets to is if you click on one of these, very similar to how you would have tags in a Docker container, is someone's done all the hard work of quantizing these and optimizing these for you. So the open source community here, and if I click view all tags, there's probably even more, has put 22 different versions of this single model at different speeds of repetition, different speeds of inference, different speeds of accuracy already for you. And you can stand on the back of the work that someone else has already done. Things like fine-tuning and quantizing are very computationally expensive. So if someone's done it once, we should always reuse it. I always, whenever I advise companies, use what's on the internet. This is an open source model. You're here because you don't want to train one yourself. People have already optimized them for your use case, and you can pick up on that as well. So I'm going to pick a 4 gigabyte model, and we're going to give the conference Wi-Fi a run for its money. And what will happen here is actually this is downloading behind the scenes. This will download a model from that particular repository, put it inside this environment, and when the download is finished, we can start prompting it. And that's how easy it is to get an end user to download, install, implement, serve, and host a large language model. I'm going to open up one of these alongside. Hold on. There you go. So this hopefully serves the non-technical customer, the person who uses ChatGPT every day, maybe someone in your organization who's really dependent on how these things all come together, and it has all the benefits I mentioned about earlier, which is I'm not sending my data off to some provider somewhere. My data stays inside my cluster, and I retain ownership over it. I saw a hand go up there. Is that a question?
Is this have access to Google API or some search engine?
Yes. So actually, if you go into here, I've not used it before, but you can add URLs and documents into here. And I believe if I had 2 hands to press the hash key, I would. But you can put URLs into here, and it will do scraping alongside that, how ChatGPT does as well. So you can provide a URL to some docs, go look at that, learn it, including the context window, and then refine my prompt from how that's being done.
But you can ask Google also?
It doesn't ask Google. It does go to a specific URL. The problem with asking Google is Google's terms of service. And the open source community is normally very respectful of that. There are some people who use, I think it's SRAP API, which you can sign up to, which is a breach of Google's terms of service, apparently. That's a particular solution for LangChain, etc. I'll show you something that might help you in that direction in the next repository.
So is this app called Ollama? What is this?
This is called Ollama UI. I think now they've renamed it as Ollama Open Web UI.
So can I run this Ollama on Civo instead of running it on local?
This is running on a cluster,
It says localhost.
because I've port forwarded it from this cluster here.
Makes sense. Thank you.
There you go. So this is it all running inside a cluster. It's running on the NVIDIA GPU that's backing it. This MacBook couldn't produce tokens that fast, unfortunately. No problem at all.
I actually ran the Terraform building for the last 15 minutes.
I'll circle around and have a look at that in a second. But yeah, so that's the user interface. For the non-technical user, if someone wants to pick this up, this might be useful for automating, service teams, customer service. I was having a conversation earlier with someone who said, our sales reps don't do cold contact anymore. They basically make a prompt that scrapes a LinkedIn profile and says, write me a bespoke approach for this individual person for outreach. These types of things I think are really good automation use cases that you can just pick up and run away with. Now, as it goes here, let's ask it some questions, such as, apologies. When was the City of London founded? And that will generate some tokens alongside it. It's being used at the same time to download the model, which hopefully should be finished by now. And what we'll do when this loads the model into memory, it will produce that result. Now, what's really interesting about Ollama is you can have 15 to 20 different large language models here. And what it will do is it will intelligently take them out of memory when you're running out of GPU RAM, and then it will put it back into memory for the new model when you've selected a different one. So what this is actually doing is it's probably taking that wizard LM model we just put into memory from downloading it, changing it back over to Gemma, and putting it there. Now, why that's really important is that's probably the reason 90% of machine learning applications break is NVRAM leak. So if we open a new one here, let's swap to Llama 2, for example, and we'll say, hello, Llama. Do an example prompt from there. This will then take that Gemma model out of memory, put the Llama model back into it. If you wanted to consistently load a single model into memory and you've decided exactly what you want to do from there, you can do so. There's different settings inside the Helm chart that will let you play from that. But what I really wanted to make sure you see is, it's an interesting return of prompt, is dynamic loading in and out of memory from that perspective. Now, that's a non-technical user inside your enterprise looking at leveraging an open source model to replace ChatGPT. What you probably are here to see today is actually how do I start building applications around that, and how do I start automating use cases. And as software engineers, pattern approach architecture is the way we think about things first. And actually when you're using existing ways of running applications, running web services, the way we do that seems to be microservices, endpoints, and segregation and isolation in different services. So what I've put together inside here is actually this app. It is designed to be the simplest possible way to use a large language model. This links into all the existing infrastructure you've got here around an inference endpoint. It plays nice with the user interface, which supports the non-technical users. And it also gets accelerated by the same GPU that we've got configured behind the scenes. What this really simply is a Python Flask application, but this could be something in Java, something in C#, something in any other appropriate language. It has a really simple life cycle, which is it checks to see if it's being ran inside a Kubernetes cluster. It loads the application. If it is inside the cluster, it uses the cluster's service endpoint to connect. If it is localhost, just for development reasons, it will point to an LLM that's local. It uses this OpenAI integration that I gave you an example of. And if you don't want to use OpenAI as an example, you can really simply copy and paste what's being done in these integration examples into the code and use LangChain or Llama Index, or you can use AutoGen and start building agents. But the important bit is you're doing it all off the back of an open source model and a GPU that you own. Here we're just setting up a very simple prompt, and the example that we seem to see used in quite a lot of the LLM community is write me a motivational quote. This is done satirically because large language models are really bad at motivating humans. It's the joke behind the scenes. This gives you an example of an endpoint that when hosted, I will visit using a web browser. It will call a prompt behind the scenes and it will return that prompt to me. If you take this away, you can implement something like a React framework. You can implement something like a user interface and actually build an application that's dependent on this large language model endpoint to be able to call. If I bring this over here and click refresh on this, and hopefully my port forwarding's still there, what you'll see is actually this text will be generated, as you can see. And this is actually being used in the model. It's running an inference benchmark. It's putting it through Flask, and it's returning it to an endpoint. So this is an example about how you could automate this, ideally using a framework such as an RAG or LangChain alongside that. But it gives you an idea about where you can use these types of high-performance infrastructures inside your applications. And that one probably needs to be a boot. But I think you can see, oh no, there you go, just came back to me. The only person you are destined to become is the person you decide to be, by a person a large language model made up. Fantastic. So that's the very basic framework of how this all comes together. Hopefully I've showed you a little bit of the integrations that can be used alongside that. And ideally it gives you something that if you were to go build a large language model using Kubernetes and using a GPU, this puts you a couple of weeks ahead of your development cycle. I haven't seen very many people who are giving the whole stack away. And actually if you look on GitHub right now, you'll find some Terraform. You'll find some Helm charts. You'll find some applications. But actually the really hard part is wedging all this stuff together for people to use it. The last thing I will show you very quickly is that actually inside here you'll see CI/CD, which lints this Python to ensure there's no errors, and then manages both the building of the Docker container for that application and then the deployment via Terraform. And you can actually see that inside the GitHub repository under Actions here. Fantastic. Now, there's kind of no limitations about what you can do from there. I'll take a question.
Can we run this without GPU?
You can, yeah. So if you disable the NVIDIA device, Ollama on boot will check if a GPU is available. If you disable that device plugin, mostly because it will crash if the GPU is not present, you'll enable it into CPU mode. The thing I would also make sure is inside this Terraform, under this values, I believe there is a GPU enabled flag. If you disable that, it will run on CPU. I would not recommend running the larger side of the large language models on CPU without severely quantizing them. They're called large language models for a reason. I think from memory, a 7 billion parameter model running directly on CPU normally takes about 30 seconds to return a prompt response. So it kind of slows down the process behind it. Ollama does have stuff that if you're running it locally on something like a MacBook, you can use the M1 metal or the M2 metal to accelerate some of those prompts. And that will work in a very good developer workflow with some of this is in a container code that I've put in the example application. Does that make sense?
So there's another, in the values.yaml, there's number 1, 2, 3, we can add. What if I said 5? Is it going to parallelize them?
So what this will do, you can configure this inside Ollama. There's lots of different ways you can manage this, right? You might take one model, and you might split layers of that model across 5 different GPUs. The reason you would do that would normally be to accelerate a really large model. You'd put a chunk of layers on one GPU and a chunk of layers on the other. What you typically see is that has a particular point where loading and unloading those layers onto the GPU becomes the bottleneck for how you would access it. If you have a single memory model loaded into that, you can also do the vice versa of that and effectively load multiple models alongside each other. So you might give one of the GPUs to Llama 2. You might give one of the GPUs to Gemma. In that situation you saw earlier, where Gemma took a couple of seconds to turn on and come over, you wouldn't have that setting if I had 2 GPUs and 2 models. No problem at all. The other thing to call out here is obviously the persistent volume to store some of these models behind the scenes. These models are large. I recommend storing them directly on volumes. There's a lot of approaches here as well that people talk about mounting them using S3 buckets, or in the Civo world on a Civo volume. Sorry, Civo object store. The majority of the time your end user is going to be seeing a loading screen, is either loading that into the GPU memory or downloading the model directly. And one of the caveats I will call out is open source models don't want to pay loads of money for you to have really high bandwidth access to download their models. So Llama stomachs a lot of that cost on their behalf. But keeping them cached and keeping them open lets their bandwidth go to more people using those open source models. You'll see here as well I've got Lava and Mixtral. And effectively these models are the models it will download initially on the deployment when it comes out. Awesome. Any more questions? I can see a couple of half hands. Nope, fantastic.
Yeah, quick question.
Awesome.
When you download these models, is this mixed up to a version?
Yes. So this will effectively download the latest, right? If you go into the Llama user interface here, and every other, I've used Llama in this use case, but the majority of other model providers would do something very similar. This is the latest. You might see something here around 7 billion parameters. This is 7 billion parameters quantized to 4 bits. And you'll see a variety of these options put alongside it. You very rarely, I think a good example of this might be Gemma, because Gemma had a 1.5 update come out recently. You very rarely see updates on models without it being completely refactored. And a good example of that is we had Llama originally, and then Llama 2. The 2 wasn't a version, it was a completely new model that's put out together. And this goes to show about how the architectures which are underlying these models are still constantly changing, and the frameworks are still constantly moved. Gemma, you can see here, you do have a version, and this is one of the first examples I've seen models using this directly as an incremental version. The majority of the time, you will see variants of the model. So here's an instruct model, a chat model, and different versions of the quantize. Does everyone know what an instruct model is versus a chat model? So a chat model is optimized for this type of conversational UI. An instruct model is optimized for this particular type of agent process. So you can see here, this isn't necessarily asking for me to respond in a human way. It's asking me for direct access in an instruction, and then to return a direct result. So let's give this a run, shall we? And hopefully this should still be in here. Fantastic. Okay, so you've probably seen a couple of different ways to build large language model applications. The common one everyone talks about is RAG, right? Retrieval Augmentation Generation. That basically takes the context window. The context window is, in this particular example, what you fit inside these prompts as context. So in this particular example, the context I'm providing is the system. If I said, you're a helpful assistant here who tells jokes about Kubernetes, the end user wouldn't have to prompt that they were including that the jokes were in the context of Kubernetes. Transparently, large language models are really bad at making Kubernetes jokes. You can understand why that context window is important to be included. When you do things like RAG, what you're basically doing is including that into the context window for these system prompts. Now, what becomes really interesting, Docker's loading. What becomes really interesting is actually when you're using something like AutoGen, you're not really interacting with it as a chat model. You're interacting with it as an instruct model. And what becomes really powerful about that is you reduce hallucination chances, because I'm not asking for the flowery response that comes back. This is often responded in technical ways as what's called a temperature. And effectively, the lower the temperature, the more stern the response, the higher the temperature, the more elaborate the response. And as Docker starts to load. I'll work out why that's not doing that in a second. And effectively, with an instruct model, what you might do is ask it to, instead of return a human articulated response, return me some code. Return me an example of a project directory structure, or something alongside that. This particular example doesn't like my Python configuration for some reason, but we'll come back to that. But in this particular example, I actually ask it to generate me a Flask application. And as I said, I'd come back to this a little bit earlier. I made some tweaks, mostly to include the fact that the container was included, but that prompt in AutoGen made this code. So I wrote infrastructure here, the infrastructure wrote my application. There you go, guys. We've got a little bit of time towards the end. I'd love to take some questions and also poke if there's any opportunities here for people to build on top of it. But in the lieu of that, has anyone got any burning questions? Fantastic. What I'll probably do is pop round for anyone who's got any Terraform hanging. I think this gentleman here did. And thank you very much for coming along. All this code is online. Please feel free to use it at home.